Let me ask you something. There is a set of twins, one an astronaut, and the other works for mission control at NASA. The astronaut leaves on a deep space trip, traveling at 95% the speed of light. Upon returning, the astronaut's clock has measured 10 years, so the astronaut has aged 10 years. However, when the astronaut reunites with his Earth twin, the astronaut sees that the twin has aged 32 years. How is that even possible? In this video, we'll explain this concept of time dilation.
Time dilation is the slowing down of a clock as determined by an observer who is in relative motion with respect to that clock.
So the astronaut's twin is traveling at relativistic speed, so his clock slows down.
Now, taking the astronaut's case, both of them might not agree with each other as both their clocks were working right. But a notion of simultaneity is required in order to make a comparison of the rates of clocks carried by the two observers. If the astronaut's notion of simultaneity is used, it is found that his brother's clock runs faster than his by a factor of square root of 1 minus v square by c square, where v is the relative velocity of the observers and c equals to 299,792 km per second, that is the speed of light.
To have a better understanding on how motion affects time, let's consider the simplest time-keeping mechanism. Let's imagine two people, one in a spaceship slightly above the Earth's atmosphere and the second one on top of a hill. Both are watching a man fall from space towards the ground. Let's say the falling man is carrying a photon clock in his hand. What do the two men observe when the man falls past them? As the man falls from space, the light in his clock would appear to move in triangles to the two observers. This would mean light travels a longer distance, consequently stretching the duration of a second. This duration of a second is proportional to the length of the falling man.
The time dilation effect predicted by special relativity has been accurately confirmed by observations of the increased lifetime of unstable elementary particles traveling at nearly the speed of light. The latter experiments, furthermore, have confirmed a gravitational contribution to time dilation as predicted by the theory of general relativity. It is said that time runs slower on the surface of the Earth than it does above the atmosphere. So, in the case of the falling man holding the photon clock, the man would appear to be falling slower to the man on the hill than it does to the man in the spaceship above.
Taking it to a broader concept, different planets have different masses and thus different gravitational strengths. They also accelerate at different rates. This is what happens in the movie Interstellar, when the protagonist lands on a planet in the proximity of a black hole. The gravity on the planet is so severe that 1 hour on the surface is equivalent to 7 years on Earth. Thank you for giving us your important time, and we urge you to stay safe during the current time.